Okay, so now we have our pipeline in place, but it won't actually work yet. And the reason is that we haven't actually done any of the testing that we are supposed to do. So let's go ahead with that. We have our entry point script, and that is where most of this will going to take place. So if you remember from last time, we left it like this. So this only works in development mode for now, and we're going to build this out. So the first thing we are going to do is to actually check the RTE runtime environment variable for its value, and that will be the way that we control how this entry point script will actually work. So we will still echo this line out so we can see it in the Docker log, and then we will make a case statement here. So we will look into the RTE variable, and this is going to be closed off by something called exec, and that looks maybe a little bit strange, but this is the way that these things are named in POSIX shell scripting, like the if construction is closed by fi, so case is closed by exec. That's just the way it is. So we are going to look at this RTE variable, and if it matches the value of dev, well, then we know that we are in development mode. And let's just make an echo statement here so that we can see that we're actually in the correct mode. So we write development mode here. So that will be listed to the Docker log. We are going to need 2 semicolons here for this case exec thing to work correctly. So that's the first case we have. The next case we have is test. And again, we will echo out the mode here. So test mode. And for now, I'm just going to put the 2 semicolons because this is the one that is going to be a little bit difficult dealing with. The last one we are going to have is the production, and it's, again, we echo out here, production mode. And we are going to close it off by a couple of semicolons to begin with. So far so good. So everything is set up for development mode to actually work. So let's continue with the production mode, because that's actually going to be very easy. So we are going to use exec uv run, and instead of running guestbook.py this time, we're going to use a Python WSGI server. That is a standard within Python web application servers, and we're going to use one called gunicorn, which is very easy to deal with and works extremely well. It's going to need the address to bind and the port number, and that will be 0000 port 3000. We're just using the same port that we do in development. There's no need to change that, because then we would have to deal with passing that information other places also. So no reason for doing that. It's also going to need the guestbook :app, and that is the app object within the guestbook module. So far so good. We can save this, and there's a few things we need to do now. First of all, we need to actually add gunicorn as a dependency to our project. So uv add gunicorn. So now that is part of our dependencies. And the other thing we're going to do is that we already have a environment file for our development mode. We need one for production also. So let us create that one. So it's called env-prod. And the first thing I'm going to do is I'm just going to read the development files in here, because there's a lot of things that will be identical. So here we just list prod instead. This is going to be the same, but we are going to delete the passwords here, because as you can imagine, we absolutely do not want our production passwords available in environment files checked into our version control where a lot of people can see it. So we're going to delete them from here. And then we can provide these two environment variables to the production environment in some other way. It doesn't really matter how, as long as the environment variable is available to the environment when needed. And we will later look into much more secure ways of delivering these environment variables rather than doing it via the environment file. So that is how we are going to do that. Okay, so last we have the test mode, and that's going to be somewhat more difficult. So let's also make an environment file for test mode. So that will be called env-test. And again, I'm going to read the env dev file, because that will actually suffice. We don't need to do anything other than this. So in development and test mode, we don't really care about the data, because it's just going to be nonsense data in there. But production data, obviously, we need to protect. So there's no problem putting the passwords for development and test mode in the environment files, and that will just make things very easy for us. Okay, so back to the entry point here. We can now go and look at this test mode of ours. So this is going to be a lot more fiddly and intricate than the other modes. So the first thing we're going to do here, remember when we're doing test mode, we need things to happen automatically. But the way things are now, when we run in development mode, we have to go and do this provisioning manually. And we can kind of live with that, because we just set it up and then we leave it like that and keep using development mode from there. But if you think about it, on the pipeline, it will run in a completely new environment every time, and there will not be any persistence of any image around, any volume around. So we can't really take the same approach here. So we need to do the provision automatically. And you can implement some automatic provisioning for your development also if you feel like it. I will leave that up to you. So in order to do that, we need to have a Postgres client, because this entry point script is running on the app service. And it needs to then connect to the database server and run the provisioning scripts. So there's a few things that need to be in order for that. So we are going to use the package manager apk add, and then add the PostgreSQL 17 client. So you might wonder, why am I not doing this within our Docker image? Because this Postgres client is only going to be needed when we are in test mode. So I will install it ad hoc here rather than installing it into the image. So this will have virtually no influence on our image. It will just happen whenever we run test mode. Okay, so far so good. So now that we have the PostgreSQL command, we can actually go ahead and run the provisioning script. So like we do when we exec into the database service, we have this psql command. And because we're not running locally, we need to provide a host, which is DB, named after the DB service, as you remember. We're also going to provide a username, and that will be in our environment, of course. So PostgreSQL user. And we need to provide a database name, which is also in our environment. And it's called PostgreSDB. And then we need the F option for running a command, or rather running an external script. So that will be db files provisioning.sql. So this command will do exactly the same as when we exec into the database service and run the provisioning script within the PSQL environment. Let's just, while we are at it, let's just, we can actually go up here and copy this line. Will make things a lot easier. So while we're here, we might as well do some testing. So we can use the C option here for running a SQL command. So we just do select all from book. If that fails, it should definitely succeed. If everything is all right, that means the provisioning script has actually run and everything gone well. Then that should be, then that should succeed. We are going to do something similar to this. So let me come down here and paste this yet another time, because there's one thing we need to do here in test mode. When we are on the CI pipeline, the test mode is going to run within a new environment every time, so it's not going to be an issue there. But when you run the test mode locally, you actually want to have exactly the same setup every time. So you don't want Reminisce data from the last run to remain in the database. So we are going to run a command here and say drop table book. So this is only going to run in test mode, so that should be absolutely fine. And you might argue, what if I'm going to run this on the production server? And you're absolutely right, that would be a catastrophe. So we are going to handle that later. But for now, let's just leave it like this. Okay, so with that we can continue. So we need to install a few more things here. We're going to install curl and grep, because we are going to use these tools for actually testing our system. So the first thing we need to do is we need to start the G-Unicode server. So we'll say uv run G-Unicorn, and we'll give it the same 0000 port 3000 and guestbook :app. And now things will differ a little bit from the development mode and the production mode. When we're in production mode, as you can see at the bottom of the screen, we start the the G-Unicorn server and it will serve our app. And that is exactly what we want to happen. But in this case, we actually don't want just sit and wait for some requests to come in, because we don't want to make them manually. We want to make them automatically. So how are we going to run the test if this command here will actually block and will not continue other than when the G-Unicorn server exits? So there's a very smart way in shell scripting for doing that, and simply adding this ampersand at the end of the line. So this will make it a synchronous background task, and we can simply go on another line, and whatever we write down here will then continue in the foreground. Because it might take a little while for the G-Unicorn server actually to come up and be ready, we are going to sleep for 10 seconds here. And that is only to make sure that the G-Unicorn server is definitely up and running before we run the test. 10 seconds is probably overkill, but better safe than sorry. So we can go ahead and declare a URL for our test here, and that will be http://nginx. That will be the endpoint that we are going to address. Okay, we are going to define a pattern, which will be simply hello. And the idea here is that we have some pattern, then the pattern is some text that we would expect to be in the response once we make a request. So this is the pattern that we're going to look for. The request we are going to make, or rather, it will return the response, right? So we will name the variable response. And that will be the output of some command that we're going to run. And the way that we can do that is to do a shell substitution in here, which means that whatever is here within these dollar parentheses will be run as a command, and it will return some string value, and that string value will then be the value of the response variable that we have declared. So that is a very smart way to do this. So we'll make a post request, because remember, we will have an empty database. We are going to send some data along with it, and that is going to be tx equals the pattern that we are looking for. And rather than just writing hello here, I'm going to actually use the pattern name, so that if I change the text that I'm looking for, it will change here also. I will also provide a host name, and that will just be something me, and that's not very important. We need to provide this to a URL, and that is going to be URL. So with that, we have this pattern hello. The response variable should be set to the output of running this request against our Nginx server. And because we have this payload, and we know that when we make a post request, the application will actually return the data that has been recorded in the database. So the string hello should most definitely be there. Right. So now we simply need to test if that is the case. So we say if echo response we take and pipe that into grep, and we want to look for pattern. So here we say tx equals $pattern, So if that goes well, we can say echo found pattern in response. So far so good. If it doesn't go well, then we have an else clause here, and we say echo error did not find pattern in response. Okay, but the pipeline and the way that we are testing will actually not look at this this output of echo here. This string is merely a string that is going to be put within the log. We actually want to make sure that this script fails if the pattern is not within the response text. So here we are going to say exit 1 because, as we discussed earlier, if we exit with an exit code that is not 0, it indicates an error. So that will be taken care of like that. There's a few more things that we want to do. We want to run this uv install pip audit and uv run pip audit, and we want to make sure that we exit with an exit code of 1 if there are any errors, if there are none, if there are some of our packages in our dependencies that have security vulnerabilities. And we will know that by doing this or exit 1. So that should take care of our testing. Okay, so there's a few small details that we want to take care of. If we go back to our compose file, now that we are running our provisioning script from within the app service, we actually need to give the app service access to the provisioning script. And we'll do that by simply making a bind mount volume exactly the way that we did for the database service. So that will be exactly the same here. db files, like that. And read-only access will be fine. So far so good. That will take care of giving the app service access to the provisioning script so that it can run it. The other thing I mentioned was that we actually rather want to have separate databases for our environment, runtime environment modes. And it actually turns out to be very, very easy using Docker Compose, because we can simply name the volume down here, and so we can say guestbook db dash and then suffix our RTE variable here. This way we will have a guestbook db dev, guestbook db test, and guestbook db prod. So now even if someone accidentally or intentionally runs RTE equals test on the production server, it's not going to drop the table of the production server no matter what. So this is a very nice feature in order to make sure that that will never happen.